Welcome to the course on Introduction to Mathematical Modeling using MATLAB, with special emphasis on numerical analysis. Many engineering problems are so complex that it's very difficult to get analytical solution, and thus we may need to rely on approximation methods to obtain usable answers. Numerical methods are nothing but the techniques by which mathematical problems are formulated so that they can be solved with arithmetic operation. And though there are many numerical methods, they have some common characteristics. They involve large number of tedious arithmetic calculations. But why we go for numerical methods? Because it's extremely powerful problem solving tool. It is capable of handling large systems of equations, nonlinearity, and complicated geometries, which are generally impossible to solve analytically. Many commercial software such as ANSYS, COMSOL, MIC use numerical methods. But many problems cannot be approached using commercial softwares because they are designed for certain specific purposes. And that's why if you are conversant with numerical methods and computer programming, you can design your own program and solve your own problem without buying any expensive softwares. And by that, you will be saving a lot of money. Numerical methods can be categorized into following subject areas, and this is given by Chopra and Dr. Canal in their books Numerical Methods for Engineers. Numerical methods first category is root of equations. Some of the equations they are so complex we cannot solve for all locations, but we can find out the roots at certain point. For example, here this f of x value is 0 at this point, and by solving this we can find out the value of x. This is valuable for engineering design where it is impossible to explicitly solve design equations for the parameters. System of algebraic equations can be solved using numerical methods. For example, here we have two set of linear equations, and the solutions lies in the intersection point of these two lines, and we will get these two equations, and we can solve for x and y because a value and c values are known. And such equations arise in engineering problems, for example, structure, electrical circuit, fluid network, and they also encountered in curve fitting and differential equations too. Optimizations is a very powerful tool used in the engineering design, and generally we try to find out maximum or minimum value or optimum values. Many numerical methods uses optimizations to arrive at the proper approximations as a solution. Curve fitting can have a regression or interpolation. In regression, generally there are a lot of error in the data, and that's why to find out some trend in the data we go for regression. Generally, experimental data will have such errors, whereas in interpolations the relative error is very low, and we try to predict the intermediate value using interpolation techniques. Integrations is a very powerful tool, and it's heavily used in engineering, and it's generally we try to find out the area under the curve. For example, here from a to b, this is integration is basically area under this curve for this function f of x. Ordinary differential equations are basically developed. Many physical laws are developed on ordinary differential equations. Basically, that's nothing but the rate of change of the quantity, and it can be divided into initial value or boundary value problems, as here this y is a function of t, and the tangent to this point is basically rate of change of this y, and we can solve this y as a function of t. Partial differential equations, when the behavior of the physical quantities is depend upon the rate of change of with respect to two or more independent variable. For example, here x and y is depend upon x and y are independent variable, and which changes the value of u, and we get these equations. And there are many methods to solve these partial differential equations, and numerical methods are the best one. And to solve these all numerical methods, we need to have a strong mathematical platform, and we will be using MATLAB. And our course is designed in this 9 modules, which start with simple calculation with MATLABs, and then how to do simulation. And this course is based upon this book by Ota and Danier, An Introduction to Programming and Numerical Methods in MATLAB. And we will follow the module as given in this book. So let's start our journey to learn numerical methods using MATLAB. And if you like this video, please subscribe and share.